Okay, looks like I've got some vocal and I'm going to record this. This is an intro to the course. I sent everybody a schedule about what was happening the week of the 19th to the 23rd. And for the 26th for Monday the 26th to Friday the 30th, as I noted there, the Management 3603 should see this pre-recorded screencast, and it will be posted for you to take a look at. Now, what will happen is there will be an invitation placed in the announcements section, and then you'll be able just to simply, the invitation will have a link to a YouTube video once this is converted. For the week of the 19th and 23rd, of course, class started the 22nd, which is Thursday. Then Friday the 23rd was a time for all of you in Management 3603 to just simply come into Canvas and take a look at the review the materials that are in here. So want to get started with that, and we'll just go right over there to the Canvas room. And if you've had a class with me before, this should be very familiar, the different modules and the section which has the course resources. Okay, here are the announcements. Start with that area. Of course, I have that announcement I posted, and I send an email to everybody as well for August the 19th to Friday the 30th. And it's going to be a little bit sketchy here because the 2nd of May, pardon me, the 2nd of September will be Labor Day, so it's unlikely that, well, we won't be having classes. So what I will probably do is a physical class on Wednesday the 4th. We'll go from there. We'll take a look at it. Here's the announcements section. And in the announcements, I'll not only post things like the schedule or announcements about the course, I will also post the invitation to the meeting if I'm live streaming it. If not, I will simply post the video, link to the video at YouTube. Okay, now, that being said, let me see here. I want to go down to the back over into the home and just look at this at some of the course resources. And you can see if you've had a class with me before, it's very familiar. I have some for the now, of course, link here in terms of the day and time. We typically will have, this is classes in a hybrid mode. We'll have a physical class on on Monday, and then on Wednesdays we'll have a virtual screencast, and on Friday you have a virtual lab to work through, which is the assignments and the exams. Now I have some resources for you, and again, here's a link to the OBU library. Here's a link to the writing lab at Purdue University, banner. All those are, you should even be seeing those if you do. Here's a couple of sources: knowledge at Horton and insights at Stanford Business, as well as Informs, which is the group professional organization that works with folks who work in management science and operations research. And here's a link also to the Christian Business Faculty Association. And then a whole section here on course resources and policies. We're explaining the approach to the course, participation, late assignments, posting grades, exams, textbooks. These are some additional chapters from the textbook. And these are the student files from the Anderson text. We have 2 textbooks in here. And one of them is the Anderson text, the other is the Foreman text. And I'll show you that. Here are the files from the Foreman text and some other sources here. And I'm most particularly interested in you taking a look at these resources. The solver tool in Excel, optimization, and the what-if analysis, those tools. And just to give you an idea of what we're looking at, here's a link to business data roles, and you click this link. We'll take a look at it for a moment. This is from a professor over at Duke University. And basically I'll zoom it up just a hair. And what he basically is saying is that these are the kinds of skills. You can see these. We'll bring them up just a little bit more. Identify critical business problems, find and apply appropriate models for each metric, the business metrics. And in each of these, where you see under the job title business analyst, we cover all of these in the BISS courses. And so when you leave here, you have the same skill sets as a beginning business analyst. In addition to the business education chat, so you have a leg up on everybody. Now, we'll go back here. And if I have the Canvas course schedule resources, these are different places in Canvas where you can look at when assignments are due primarily, and just to look at the schedule. If you really want to see the schedule in its fullest or easiest, quickest form, you're going to take a look at that over here, excuse me, in the modules. Here's the syllabus for the course, and then I have a syllabus attachment for the fall semester. Now, as I mentioned in the announcement that I sent everybody about the week of the 19th to the 23rd, I said, come over here and peruse, take a look at the website, and kind of familiarize yourself with what's over here. And so that's what I intended for you to do. Now, I'll click on this link, and as I noted, I was going to post a video that will kind of serve as an introduction. But I wanted you to come over here and take a look. Friday the 19th, pardon me, Friday the 23rd, and then take a look at this video as well, which would suffice for that course introduction. Now you'll see that we're going to come down to Module 1, and that's the week of the 8th, the week of Monday the 26th, Monday the 26th, Wednesday the 28th, and Friday the 30th. As I noted to you, Wednesday and Fridays are virtual days. Wednesday is a screencast, Friday is a virtual lab. Okay. Now, there are a couple of chapters, and so when students ask me, okay, what should I read for that week? It's usually going to, your readings are really going to be linked to a couple of things. Number one, any exams or quizzes that you have, all right? And you have a couple of quizzes that are due the 30th of August. And you can click on the link and it will show you how many attempts you have, etc. As you can see, it's through August the 30th, how many points there are. And then on the Nolan Plastics is a case that we will work on, and that Nolan Plastics case is covered in pages 14 through 16 and then 26 through 29 of the textbook. And then I have some links here on the Excel Easy Solver. That's a link to a resource that explains the Excel solver. We'll be using it. And I'll show you real quickly here. When you're in Excel, and you guys will probably have to add the solver to your computer, and I'll just show you what you'll want to do is to add solver is you click on File, you go to Options, okay, and you're going to come in here and you're going to click on Add-ins. Now, if solver is not active, as it is in my machine, you'll have to click on it to enable it, then click Go, and it will be added to your toolbar. Or, pardon me, you'll get the analysis tool pack, and then you'll have to click to add it. Once you do, you'll see it. You'll click on Data, and you'll see it over here. Okay? So we're going to be using Microsoft Solver quite a bit. We'll also use the what-if analysis. Okay? Now let's open Solver up for just a moment. Let's give me that business. Well, all right, I've had some problems with it, so hopefully you won't. Let me click the data analysis tool pack. Okay, that's there. We're good so far. All right. I've had some problems with Excel with getting the solver to operate, so I'm probably going to have to get it repaired when I get back. Anyway, here's a link to the Easy Excel Solver, okay, and the GRG nonlinear, which is another function within Solver, and the evolutionary. And here is a key. After we do a case, I'll introduce you. I'll have a key and I'll walk you through what I was asking you to do. Okay. Now, I want to go back up for a few minutes to the course resources. And before I do that, I want to make sure that we are on the same page in terms of understanding the flow. Now, we're going to look at chapters 1 and 2, okay, in the Anderson text. And I have the text online in VitalSource. So we'll go to the contents. Now we'll go over to chapter 1, which is in an introduction. And I want you to read these materials. And the authors start off with the difference between problem solving and decision making. And this is a key section of the book where they talk about the 7 steps of problem solving. Now, this is a course in management science. So what we're doing here is we're applying the scientific method as a means to understand or deal with problems in management. And we are looking for what we call the optimal solution, the best solution available given the resources we have to work with. Now, the problem-solving process, scientific process, involves these 7 steps that are listed right here. This is right up from your text. And then we move into decision making, which is different. It's one thing to solve a problem, to find a solution. It's another thing to either use the solution we find or not use it. So the decision-making process is we either take the solution that we found, or we simply don't utilize that decision. Now, we're going to run into some problems here as the authors talk about here in terms of what we call single criterion decision making versus multi-criteria. And what they mean is when we go to solve a problem, if we use management science, we are going to say, okay, here is the key variable or factor or condition that I want to use as the criterion for the problem, okay? I want to achieve a certain level of sales. I want to achieve a certain level of sales. I want to save a certain amount of money. And that's a single criterion. If I have multiple criteria, for example, like I have a cost constraint in terms of transportation costs, and I have a capacity constraint, and that is how much I can make or receive at a given location. Then if I've got to have that type of mixture, which we call a transportation problem, then I'm talking about a multi-criteria problem, multi-criteria decision-making problem. So it's important for you to understand. So again, over down here down in the text, the authors talk about this: defining the problem, identify the alternative, determine the criteria, evaluate the alternatives, and choose an alternative. And then they walk us through a problem for a person who is trying to figure out where they want to take a job. They have some offers, and this person has created some criteria. So they have these alternatives, okay? And then they have some criteria involving the starting salary, the potential for advancement, and then the location. So here we see over here in figure 1, the process of decision making, okay, versus problem solving. We can see all the steps that are involved in problem solving. In decision making, we stop at the choice of an alternative, but problem solving takes us to 2 different steps. We implement a decision and we evaluate the results. Now, the authors are going to walk us through here in figure 1, 2, the difference between structuring a problem, okay, and analyzing it. In order to solve a problem, management science says if we're going to do it in the most effective way, then we have to structure it. We have to understand the problem. And here we define it, as they note. We identify the alternative outcomes, and we determine the criteria. And then once we've structured the problem, then we analyze it. We evaluate those alternatives, and we choose an alternative. And if you have had a class with me, or I'll talk about it here, we try to work through a process by which we look at known and unknown alternatives versus known and unknown states of nature. And I'm going to annotate us for a minute here. And I'm going to draw. Start with a square. Okay. Divide this square up. Okay. And then I'm going to use the text. And this will be known. Now let's pop this over here. And then below here, I'll put the text. So we have known and unknown. Let's say these are our alternatives. And then we repeat up here, and I'm just going to put a K. I'll put the text here. Okay. And then up here, this would be an unknown. And let's talk about this for just a moment. Now, here we have just a convenient little way to look at this. Here on the x-axis, here at the top, we have what you would call alternatives. States of nature, conditions, the situation. And there's a certain amount of it that we know and we understand, and there's a part of it that we don't understand. That's unknown. Then we have alternative responses we can choose, and that's what's known and unknown. And so you can see if we're dealing with a known problem and we have pretty much a known alternative or solution or course of action, that's pretty easy. If it's a known problem but it's unknown in terms of what to do, well, that's a little bit different. If we have a known solution or we have a whole set of potential alternatives or reactions or solutions we could choose or decisions we could make, but we're not sure the situation, that's a whole different type of scenario. And then, of course, if we have an unknown set of alternatives and an unknown problem, we have what we call a novel situation. Okay? So, we'll go back to this and we'll clear those out. But this, again, we'll emphasize the fact that in order to analyze a problem, we've got to understand it so that we can evaluate the alternatives. We have to identify those alternatives based on our decision criteria and then choose an alternative. They walk us through the issues of model development and the different types of models, iconic models, analog models. Iconic models are physical replica. Like you'll see somebody make a scale model of a car, for example. We have analog models. They're physical, they're like a flow, for example, a flow chart. Then we have mathematical models. And here the authors introduce us to the concept of optimization. And here they give us a problem, okay? And we have an objective function, that is a goal that we want to achieve, okay? And it's subject to a set of constraints, and they give us the narrative there. We want to maximize profits, and it's subject to the fact that we must maximize profits, okay, using labor. They're talking about labor hours here, production time, excuse me, that must be equal to or less than 40 units. Okay. And so we're building this mathematical model. The advantage of this, and then the ability to put it in a solver, is it gives us potential outcomes. Before we go too much further, we want to talk about also controlled inputs, mathematical models, and output. What's controllable, what's not controllable. And we'll use a mathematical model to be able to identify these decision variables and the environmental factors. Notice the things that are controllable that we, like for example, our internal operations, then those things like the external environment we have no control over. The author's going to walk you through the difference between stochastic and probabilistic models. We'll be working more with probabilistic models. But here's our model development. And then they show us the model solution. Now, here's the production quantity. Okay? Let me go over here for a minute, and I want to go back here to the annotation. I want to clear all my drawings. There we go. And you'll notice that we have how much we could produce and the projected profit. And is it feasible? In other words, are the hours used less than or equal to 40? Yep. Because remember, it's 5x. And here we can produce production quantity of 2, projected profit. And you can see the alternatives, the projected profit, our outcomes, the total hours of production, and is it feasible? You'll notice we come into a point here where it's not feasible. And they give us a problem here with this supply chain problem and cost and production volume. And there in the Nolan case, we're going to look at that in terms of using the total cost model. And here's a revenue and volume model. And they talk about, I guess, reacquaintance with marginal revenue. That is the value we get from each additional level of output. Then break-even analysis. The authors are going to walk us through how to do some of this production stuff, but linear algebra and then graphing it. I'm not all that excited about you doing it. Frankly, I think it's somewhat a waste of time. Solver will show you the optimal solutions. It will do that for you. Walk us through some of those techniques. And let's go back over here to the contents. And over here in Appendix 1.1, you could see using Excel for a break-even analysis. And here's Nolan Plastics, okay? And that's the case that you'll be working on. And the due date is noted there in Canvas. But the bottom line is, here's the fixed cost that you have. Here's the variable cost per unit and the selling price per unit. Okay. Now, we know that the contribution margin is the selling price per unit minus the variable cost per unit. So for each unit they sell, they make $5. The variable cost, that is the cost that change with the level of production, is $2. So their fixed cost is $3. Okay. Now they have a given of a fixed cost of $3,000. Let's say, okay, let's look at this, and here's the model, mathematical model we've put together. It makes a lot more sense. It's a lot more palpable for us when we put it into like a spreadsheet. So then we can see what it's going to look like, and we put it into Optimizer. And here we see the production volume is going to be 800. And the total cost is obvious. It's going to equal B3, which is the fixed cost, plus B5, the variable cost, times the selling price, times the production volume. Okay, so the total cost is going to equal B3, which is going to be the 5,000, plus B5, which is the variable cost per unit, 2 times B12, and we're going to make 800 of these. So the total cost is going to be 3,000 plus 2 times 800, which is 16, which will be $4,600. The total revenue is going to be the selling price, which is there in B7, times B12, which is production volume. So the total revenue is going to be 4,000, which is going to be the B7, okay, times B12. So we're going to make $4,000. The production costs will be 3,000 plus 1,600, which is $4,600. And the total profit is going to be B16 minus B14. Let's just look at this again for a moment and talk about this, because we're using the total cost equation. Remember, total costs equal fixed costs plus variable costs. Remember that fixed costs are those that don't change, those that stay the same. And then we have the variable costs, which are cost things like labor and lighting and materials. Those change with the volume, those change with the volume of production. The more stuff we sell, the higher the variable cost. So look at this again. Let's take a look for just a minute. The total cost for this is going to be B3, which is the fixed cost, 3,000, plus the products of B5 and B12. So B5 is $2 a unit, and B12, we're going to make 800 units. So the total cost, okay, at making 800 units is going to be 3,000 plus 2 times 800, which is 1,600. So it's going to be $4,600. Our revenue is going to be 5 times 800, which is 4,000. So our total costs indicate that at 800 units, we're losing money. Okay. And they walk us through that process. As you can see over here in this figure, so we use Optimizer to say, okay, well, if I'm given the constraint of, and here are my constraints, the fixed costs, the variable cost per unit, and the selling price per unit. How many of these can I make to break even? How many can I make? How many can I make and get a profit? And they walk us through using the goal seek. So, and they walk you through that process using known products and using the goal seek in Excel. And when you, if you click on the Excel and you click on the data, you'll see it, the what if analysis, the scenario analysis, and there you see the goal seek. And goal seek is easy, very simple function to use. We set the cell, we choose the cell, and then we choose the value that we want it to be, and then we choose the cell that we need to change. We click OK, and it's going to tell us if it'll work or not. What kind of, it will tell us how many units we need to sell. And there they say at this point, we're going to have to sell 5,000 units to break even. And this is typical of the cases that we're going to go through as we walk through the course. Nolan Plastics will be our first one. And I have a space there for you to upload it. As noted before, it's pages 14 through 16 and 26 through 29. And upload the case. We'll upload it on the 30th, and I'll talk about what's the solution. Of course, we see it in there, but the whole point is this, is to get you acquainted with using these. And there will be some times where I will give you a solved case, and then I'll say, okay, change the variables. And you can note right here for this very first case that you're going to do, here I'm going to have you take that Nolan Plastics case, and you'll find it in the Anderson student files. And I'm asking you to use goal seek to change the selling price to get a total profit of $5,000. And then use the goal seek to compute break-even volume, and then use goal seek to compute the break-even fixed cost. And we'll walk through that process. But I want you to, part of this is that you try to do this using the Nolan files are there in the student files. And that'll be pretty typical of how the course will work and what we'll do. So I want you to take a look at chapter 1. I'm not going to take the time to go all the way through chapter 2. It covers an introduction to linear programming. And how we do that. And here they'll introduce us to a simple maximization problem. You'll notice we have our constraints. The production time, and we have to spend a certain amount of time with these two different models of bags. This is the paring case, and the authors walk us through each of those constraints. And then we have to define the decision variables, and in this case, the decision variables decision variables, how many bags we want to make of the standard bag, how many we want to make of the deluxe. And we'll walk through that in some more detail. So that's gives you an idea of what we'll be doing the first week, the 26th through the 30th. Then, of course, there's no class on Labor Day, and then we'll have a Wednesday session that deals with M&D chemicals, and we'll talk about the left-hand side and the right-hand side of the equation. Well, I think that will give you an idea where we're headed, and I'm going to go ahead and stop the recording, and then I'll post this over at YouTube when it's ready to go.